This screencast is all about ellipses. Now, an ellipse is defined as a set of all points x, y, the sum of whose distances from two fixed points, foci, are constant. So, let's say you've got one focus here and another focus there. And if I add that distance there, and I add that distance there, no matter where I am on the ellipse, the sum of the distance from this point to the ellipse and then from that same point to the other focus is going to be constant. So the sum of these two red segments will equal the sum of those two blue segments. Think of it as a string, and you've got a pencil, and you keep that string tight and you draw it around, and the ends of the string are pinned down. You're going to get an ellipse out of it. Okay? Alright, so ellipses have standard forms of equations just like parabolas do. And if it's x squared over a squared plus y squared over b squared equals 1, then you have a horizontal major axis where this point is at a 0, and this point here, called a vertex, is at negative a 0, and the origin is the center of the ellipse. Now, how do I know what a is? A is always the biggest number. Okay, so that's how I knew it was a horizontal, because the biggest number is underneath x. Right here is our minor axis, and this is going to be at 0, b, and this one is at 0, negative b. Now, if the bigger number is underneath y, then we get an ellipse where the major axis is vertical. Okay, and now we're at 0, a, and we're at 0, negative a. Okay, let's do some examples. So I've got x squared over 16 plus y squared over 49. That means that I'm going to go to 7 and negative 7 on the y-axis, because 7 squared is underneath y squared. I'm going to go negative 4 and 4 on the minor axis, which is horizontal, and I just connect the dots. How about the foci? Well, it turns out that they're located at C, and C squared is equal to a squared minus b squared, which in this case is 49 minus 16, which is going to be 33. That means C is plus or minus the square root of 33. Now we can estimate that. That's going to be between 5 and 6, because the 5 squared is 25 and 6 squared is 36. So it's going to be between 5 and 6, and it's going to be closer to 6 than it is to 5, because 33 is closer to 36 than it is to 25. So there's one focus, and there's another focus. Well, we don't have to have an ellipse with the center at 0, 0. If we want to translate it, we do it like any other thing. We just subtract h from x and subtract k from y. So, let's say I want to graph x minus 3 squared over 25 plus y plus 5 squared over 9 equals 1. We're going to need to find three things: the center, the vertices, and the foci. Well, the center is pretty easy. That's going to be at h, comma, k. Notice that it's x minus 3, so the x-coordinate of my center is positive 3, y plus 5, so the y-coordinate of my center is at 3, negative 5. I'm getting tired of using red, so why don't we do blue here, okay? Alright, so I'm going to go to 3, negative 5, and there's my center. Now everything's going to be measured from there, okay? So I'm going to draw some kind of temporary axes here, okay? And in the horizontal direction, I'm going to go 5. So from my center, I'm going to go back 1, 2, 3, 4, 5, and forward 1, 2, 3, 4, 5. So there's one vertex. So I'm at negative 2, negative 5, and we are at 8, negative 5. Okay, going in the vertical direction, I'm going to go up 1, 2, 3, down 1, 2, 3. And so on the minor axis, my vertices are going to be at 3, negative 2, and 3, negative 8. Okay, foci. Well, C is equal to the square root of 25 minus plus 9. Nope, I was right the first time, wasn't I? 25 minus 9. And I should have put plus or minus in front of this, right? Plus or minus the square root of 16, which is plus or minus 4. So on the major axis, the foci are always on the major axis. I'm going to go to the left 4, 1, 2, 3. So put 1 there. And to the right, 1, 2, 3, 4. There's my ellipse. Let's go ahead and write the coordinates of those foci. So that's going to be at negative 1, negative 5, and 7, negative 5. So that's about as hard as it gets when you're graphing ellipses. So what if your equation isn't in standard form? And so I want to convert this polynomial into an ellipse that will give me a standard form. Well, I'm going to group the x terms together, leave a space, group the y terms together, leave a space, and put the constant on the other side of the equal sign. I'm going to factor out a 9, and a 25 from the y terms, and I bet you know what we're going to do. We're going to complete the square inside the parentheses. I'm going to take half the middle term, which is 2, square it, which is 4. Now I'm really adding a 4 times 9 to both sides. Now I'm going to take half the middle term of the y's, which is 1, square it, and I'm adding a 1 times 25 to both sides. So what do we get? We get 9 times x minus 2 squared plus 25 times y minus 1 squared equals negative 24 plus 25, which is 1. Okay, this is looking really close to a standard form, except we've got this 9 and this 25 being multiplied. And I need to get something underneath the x minus 2 squared and underneath the y minus 1 squared. So I'm going to convert this multiplication to a division. I'm going to say x minus 2 squared, and then instead of multiplying by 9, I'm going to divide by 1/9, and y minus 1 squared is going to be divided by 1/25. So that means that my a squared is 1/9, which means my a is plus or minus 1/3. My b squared is 1/25, so my b is plus or minus 1/5. And that's enough for you to finish graphing that if you wanted to. Okay, well, what if I gave you some pieces of the parabola and asked you to find what the equation was? So we know that the ellipse whose vertices are 0, 5, So there's 1, and 6, 5. There's another. That means the major axis here is 6 units long, and the minor axis is 4 units long. Well, where's the center? The center's in the middle of the major axis. It's the midpoint of the vertices. So the center, remember the midpoint formula? It's 0 plus 6 over 2, comma, 5 plus 5 over 2, and we get 3, comma, 5. So at 3, comma, 5 is our center. And from the center, I'm going to go up 2 and down 2 because we were told that the minor axis is 4 units long. Okay, so what does that mean A is? Well, remember that the major axis is 2A, so that means that A is going to be 3, and the minor axis is 2B, so B is going to be 2. And since the major axis is horizontal, we're going to put A squared underneath X. So I've got X minus 3 squared over A squared plus Y minus 5 squared over B squared equals 1. And you've got yourself the equation of that ellipse in standard form.